Hello students, I think yesterday's topic, that is Boolean logic and logic gates, everything explained. I think everything is clear to all of you. So in the last video session, I have already told you that DeMorgan's law, proof of DeMorgan's law will be explained. That will be uploading soon as different videos. So in this one, I'm going to do that one. So DeMorgan's law, there are two laws of that is DeMorgan's law of union and DeMorgan's law of intersection. So the complement of the union of two sets is equal to the intersection of their complements, and the complement of the intersection of two sets equal to the union of their complements. These are called DeMorgan's laws. Okay, so I'm going to explain the two methods. I'm going to give you the proof by using algebraic method as well as which one, truth table for the first law. Then you will be able to do by yourself the rest of the second law by yourself. Okay. So let us see the proof. A union B whole complement equal to A complement intersection B complement. We need to prove. First, I am going to explain with algebraic method, and second, after that, I will be explaining with truth table. That will be very simple to all of it, and also I am going to explain that to get a very clear idea about truth table also. Okay. So for that, my first statement, I'm taking two sets P and Q. Let P equal to A union B whole complement. That means LHS of the law. Then Q equal to A complement intersection B complement. That is the RHS of my DeMorgan's law. Okay. Then these are the two statements first I am considering. Then after that, the assumption is let X be an arbitrary element of P. P means what? A union B whole complement. So I'm assuming that X be an arbitrary element of P. That means A union B whole complement. Okay. From these statements, I can write X belongs to which one? A union B whole complement. X belongs to P implies what? X belongs to A union B whole complement. Okay. Then from here I can write X belongs to A union B whole complement. Okay. From this it implies X not belongs to A union B. Okay. X not belongs to A union B. Then this implies X not belongs to A and X not belongs to B. This implies X belongs to A complement and X belongs to B complement. Okay. So from this statement, I can write X belongs to A complement intersection B complement. What is A complement intersection B complement? Q. So X belongs to Q. From this statement, I can derive that X belongs to Q. So from where we started, P equal to A union B, X belongs to P. So X belongs to P as well as X belongs to Q. That means X belongs to Q means it belongs to in two sets P and Q. So I can tell it as P is the subset of Q. Okay. So from this I got the first result as P is the subset of Q. So I started with X belongs to X be an arbitrary element of P. Then from this I can conclude that X also belongs to Q. Okay. So from this each step I think it is very clear. From each statement I can derive it to the next statement. So X belongs to A union B whole complement means what? X not belongs to A union B. So from this statement I can write X not belongs to A and X not belongs to B, and not belongs to A means what? A complement. So from this statement I can write down X belongs to A complement and X belongs to B complement. From this statement I can write X belongs to A complement intersection B complement. So A complement intersection is what? Q. So X belongs to Q. This implies P is the subset of Q. I think it's very clear. Then I am going to prove next one. Okay. So my first result is P is a subset of Q. Then again, my next assumption is let Y be an arbitrary element of Q. So what is Q? A complement intersection B complement. So Y be an element of Q, then that implies Y belongs to Q. So I can write down Y belongs to which one? Y belongs to A complement intersection B complement. Okay, I can write Y belongs to A complement intersection B complement. This implies Y belongs to A complement and Y belongs to B complement. I can write down like this from the previous statement. So I can write Y not belongs to A and Y not belongs to B, because Y belongs to A complement means not belongs to A. So I can write down. From this statement I can write down Y not belongs to A union B. Okay, Y not belongs to A union B. Then means Y belongs to A union. This implies Y belongs to A union B whole complement. Okay, so this implies Y belongs to P. A union B whole complement means P. So Y belongs to P. So Y also belongs to Q and also belongs to P. From this I got Q is a subset of P. So I got two results. P is a subset of Q and P is a subset of Q. Now we can combine these two results. P is a subset of Q and Q is a subset of P. From these two we get P equal to Q, right? P equal to Q. P means what? LHS of the low and Q means RHS of the low. That means A union B whole complement equal to A complement intersection B complement. Hence the proof. Then the same law can be proved using truth table. Let us see how can we prove with truth table. I already explained in the last session what is truth table and all. So here two inputs are required, A and B. We need to prove A union B whole complement equal to A complement intersection B complement. So two inputs are there. If there are two inputs, what will be the possible combination? 2 raised to 2, that is 2 square, that means 4. Okay, so 4 possible combinations will be there. So my inputs are A and B. Here I am trying to include. If it is not able to include, I will show it in portrait mode. Okay, so what are the possible values? 0 to 3. I have to write the binary combination 0 0 0 1 1 0 1 1. These are the possible combinations. So 4 possible combination I got it. So which are all the things I need to find out? I need to find out A union B first. That means logical addition. A union B I have to find out. A union B whole complement I have to find out. Then next A complement and B complement. Then I have to show that A union B whole complement, that resultant column, and A complement intersection B complement, that two columns are getting the same result. Okay, so A union B means logical addition. A plus B, 0 plus 0 0 1 1. So 0 1 1 1 is the result of A union B. Then A union B whole complement means negation of this one. Just invert the value. 0 means 1 and 1 means 0. So 1 0 0 I got it for A union B whole complement. Then I have to find out A complement. Just invert the values 1 1 0 0. Then I have to write B complement. I think I cannot write in this one, so I will write in landscape mode. Then it will be comfortable for you. Okay, so let us see one by one. A union B I have already written in that, and A union B whole complement also written. A complement and B complement. Till this one I have already written in the last page. So I have to find out A complement intersection B complement. Okay, so A complement intersection B complements means logical multiplication. A complement I have already got and B complement I already got. So 1 into 1, 1, 1 into 0, 0, 0 into 1, 0, then 0 into 0, 0. So I got that 1, 0, 0. So what I have to prove? A union B whole complement. That is 1, 0, 0, and A complement intersection B complement, that also got the same value. So I can write A union B whole complement equal to A complement intersection B complement. Hence the proof. So similarly, you can do that. This one derivation of this one, proof of second law also. That will be very simple.
Little bit lengthy, I think.
If you found my explanation are very useful to you, it's very clear to you, then definitely you please share this video session to your friends. Then it will be helpful for them also. Then if you are visited my channel first time, please subscribe my channel. Then I'll be uploading more and more videos, especially for 11th and 12th continuous sessions will be there. Then you will be getting notification by clicking on that bell icon. Okay. Thanks for watching.